Okay, let's get started. In PSoC Creator, we'll choose File, New Project. The target module is our Bluetooth module. We'll choose Pre-populated Schematic. We'll name it something to do with the Bluetooth chip. That way we don't confuse it with our PSoC chip if we have more than one project in the same workspace, such as what I have going on right here. Okay, let's delete all the stuff that we're not going to use. I'm sure it's all useful, like the timer is probably very useful. I'm not going to use it. We're not going to use UART. We are going to use I2C eventually to communicate to the PSoC chip, so we'll keep that. And just to get ahead, on the I2C module, I'm going to name it I2C, and I'm going to set it to Easy I2C. That sets it up as a slave device on the I2C bus with address 0x08 by default. Delete some of these other things. I'm going to keep an LED and a switch, or button rather. I know you might be thinking there is no switch on the BLE side, but it actually shares the user switch with the PSoC, and I'll show you that in the schematic here in a second. For the LED, we will select strong drive, and I named it LED to keep things simple. There's only one of them. And for the switch, sure, we'll leave it switch 1, and resistive pull-up is fine. Let's go ahead and pull up that schematic real fast. An easy way to get to this kit schematic is to type PSoC 149 schematic. 149 is the development board that we're using. Usually comes right up. Okay, so you see the switch right here. For the PSoC, it's at pin 3.7. If you scroll down to the BLE area, pin 3.7 is connected to SWBLE, which is pin 4.1 on our Bluetooth module. I guess we can actually set that up right now. So the switch is 4.1. Our LED is pin 1.6. And of course the I2C clock and data 5150. Clock and data 5150. Okay. Our pins are set. I don't need to see that anymore. Let's get into the BLE module settings. I'm going to name it BLE to keep it simple. We're going to do a custom profile because there is no pre-built profile for the Nordic UART service that we're going to use. So we'll just create one. And the rest of that is fine. Under profiles, we're going to set up our Nordic UART service. So I'm going to name this, I'll just name it NUS, Nordic UART service. It's going to have two characteristics, a TX and an RX, which if you're familiar with UART, there is usually a TX and an RX wire or pin, but this will be like a wireless version of that. So let's name this first one, let's do this, NUS RX. And the variable inside of that characteristic, I'm actually going to name it the same thing. I'm going to set the type to variable so it doesn't expect anything specific. And I'll set the length to 20. And I will delete this descriptor that comes with it automatically. I'll just copy and paste that characteristic and I'll adjust it. for the TX. There we go. Now we have to select what properties, like read, write, notify, indicate, those sort of things. And we have to set the UUIDs of our characteristics and of our service. And to get those, you can simply Google Nordic UART service. And let's try this first link right here. Okay, yep, here we go. So there is our UUID for the service. Paste that in there real quick. Okay, that didn't work. Let's try again. There it is. I'm gonna hit apply just in case. And I'll get the RX. If you notice, these are all almost the same. It's just this digit right here that's different. 1, 2, and 3. That's RX, correct? Yep, RX. Paste that in. And I'll go to the TX. Paste that one in. I mean, I could have just pasted it and changed the number, but I feel safer doing it this way. Okay, now that's the 1, that's the 2, that's the 3, yep. And our fields are all set. Okay, now let's look at the properties. On that same page, it sort of talks about it real quick. So in the RX characteristic, they want you to have attribute write and attribute write command. These are actually write with response and write without response. So let's go to the RX, and there's the write, and there's the write without response. And then under TX, it says it sends data using notifications. So under TX, we'll choose notify. And let's hit apply just to make sure it saves. Now we'll go to the next tab, gap settings. Right here, we'll name our device. So I'll just name it Kyle's BLE. Under appearance, I think you can choose any of these. I'm going to choose human interface device. I believe you can change this right here, the public address, to something that's specific to your company or your device. It might help if there's a lot of people around you that have the same setup that we're using. It might help differentiate your device from others, so less errors in a busier room. Let's go to advertisement settings. I'm going to disable the timeout for advertising, and it automatically disables the slow advertising interval. You might want to play around with slow advertising and sleep modes if you're on battery power. I'm not going to do anything with battery power, so I'm going to set it to like this. Advertisement packet. At a minimum, select local name, and that way you can see the name of your device before you connect to it. Otherwise, it'll come up as unknown, and you probably will never find it. In the scan response packet, I'm going to select our Nordic UART service. That way, when we go into the apps that are pre-built by Nordic and Blue Fruit, those apps actually look for the UART service to see if it's available, and that will help us seamlessly connect to it without any issues. Under the connection parameters, you can change these. I'm going to leave them as default for now. And then these other tabs, the defaults are fine. So that's it for the Bluetooth module settings. And there we go. So far we've set up our top design, our Bluetooth module block, our I2C block, our LED pin, and our switch pin. Next we'll get into the coding. Okay, let's start framing up our code. So once you open the main C file, be sure to click Build so that it builds your libraries based on your top design. That way when you start typing, it recognizes the functions that you're typing, and auto-completion will also be enabled. Let's start by uncommenting the global interrupt enable command. And then under that, let's start our I2C block. I'm actually going to comment that out for now because we're going to get into that later. But we are going to start the BLE block. And if you forget what it's called, you can just start typing something like BLE start and it'll come up. Don't be tricked by this one. This isn't quite right. It should be this one with the purple symbol. Now you'll see it has a callback function you have to give it. So let's just name it BLE callback. This can really be anything. It's something you have to set up. So we know it's going to be a function. So let's put it above our main function. If you put it below, it won't read it unless you have a function prototype. If you don't know what that is, Google it. So we know it's a function. I do know it's not going to return anything, but I forget exactly what goes in the function for parameters. And if you also forget, you can go and right-click the BLE module, open datasheet. Now this datasheet is a bear. It's, how many pages? 561 pages long. So I usually go to the top, click in the text up here, and then I'll hit find. And what am I looking for? BLE start. Here it is. So I know this looks strange, but it doesn't know. Because you can name it anything you want. So that's why it has this strange little part of it. And then these are the parameters. So I'm going to grab those and throw those in here. Okay. Now that's our callback function. The callback function basically, when events happen, they show up in here in the event code, and then parameters for the event come up inside this event parameter. It'll look something like switch, and it will take this, and then inside the switch, oh, that didn't tab right. Inside the switch you'll have cases. Like case 1 would be maybe the Bluetooth turns on, like it's powered up. So we'll have to look and find what that case is called, because it's not like case number 0, 1, 2, 3. I mean, they're just defined like words that we can read that are defined using different hexadecimal numbers that we don't need to memorize. So, for example, let's search. Can we search callback? Oh, maybe we'll scroll down a little bit here. Okay. So under callback functions, that's where we found our function. If you scroll down a little bit, BLE common events. So I'll click that and it'll scroll down for us. Oh, that was strange. Must be down. There it is. BLE common events. So the one that says, hey, I'm on now, is this one right here. Now on doesn't mean that it's advertising or connecting or anything. It just means that it's literally getting power or an enable signal. So let's put that in here. Oh, I think it's supposed to be lowercase. Isn't it case? I think it is. There we go. So in the case that the block turns on, we want to start advertising. Let's go and find that. There it is. CY BLE gap start advertisement. It does take an advertising interval type. Do you see that to the right? So we have to give it. We have to give it whatever that is. If we search this function, we'll find it in the data sheet. So let's go ahead and do that. So right here, and if we click it, it should go to that section. And then right down here, parameters. So we want to set it to fast. Because I disabled slow and we're not going to use custom. Right. Now, another situation, actually I think we should have a break in here. Yep. Another situation that you might want to start advertising is the case when it gets disconnected. That way it restarts the advertising. I wonder if we can get it to just show up. Is it EVT? Let's go ahead and look for it. Oh, I should have saved my spot, but let's do this to get back where I was. Is this it? Yeah, BLE common events. So down here there will be a disconnected or connected. That's probably this one. This event is generated at the gap peripheral end after connection is completed.
Hello.
Hey. So we'll grab the disconnected event. And throw that in there. And you can stack these cases like this. So when either of these happens, it'll go into these brackets and it'll break when it gets after that command. Okay, so let's set up a case in which the device gets connected and then we'll stop the advertisement. So it'll look something like this. So I'll just bring that down. There it is. And let's paste this in there. And stop should work. Yep. Perfect. Let's actually add one more thing to this section. Let's turn the LED on when we're advertising and turn it off when we're not advertising. So we'll do LED right. We'll write 1 for on, I believe, and 0 for off in this case. So yeah, that way we have a little bit of visual feedback on the board when the advertising is either started or stopped. Okay, so that is probably the bare minimum you need for your callback function. We're going to do a little bit more in here for handling data received by the phone app. But let's handle some other simple things. For example, down in the for loop, we need to tell it to process the BLE events. That's something like CY BLE process events. There it is. Okay, assuming we've set up our framework correctly and have the bare minimum code and set up, we should be able to see our device in the phone app. So let's click Program. Okay, and then I'm going to open up the NRF Toolbox app, and I'm going to select the UART service down here, connect. Since I did manage to successfully set up the Nordic UART service, I was able to filter by service. That's what it's looking for here. And the only device around that has that service available is my Kyle BLE device. So I'll click that. I don't have any buttons set up yet. We'll handle that later. In the corner there's a logs button, and we can kind of see what has happened so far. Kind of cool. So yeah, looks like we're off to a good start. Let's keep going. Okay, so let's handle the event that occurs when we receive data from the phone. Let's go ahead and go to the data sheet for the Bluetooth module. And I'm just going to search for the common events, the BLE common events section again. And somewhere down here there's the write event. If you remember correctly, we set the RX to write and write without response. So we're going to try to handle those all in one shot. Here it is. Here's the write with response. Yep. We'll just add it down here. And the case for writing without response is this one. So now if we get either of those, then we'll do some stuff that we'll figure out here in a second. Okay, before we get into the receiving the data, let's talk about the writing with response. So it's expecting some kind of response. So in this data sheet, there should be a write response function. There, yeah, that's it right there. GATS write RSP. So we'll call that, but only if our event was the one that needs the response. So we'll say if event code is equal to which one is it? This one? The one that needs a response. Then we'll call this function, and the function needs something called a connection handle. You can get your connection handle if you go in the generated source BLE event handler header. It's CYBLE con handle T. If we just start typing that, it should already be defined as something very similar. Yeah, there it is. So now that we've got the response handled, let's talk about receiving the data. Okay, so you can probably guess that it's somewhere in this event param, but we have to build a variable to hold it in a certain structure. So let's find out what that is. It's going to be related to one of these write events. So let's search for that again. There we go. So it says event parameter is a pointer to a structure of type this. So we'll try to copy that. And I don't know, we'll call this let's see, event param. How about just event data? So let's save the event parameters into our event data, and we'll force it to be this type, like this. Okay, why is it mad? Oh, it's supposed to have a... There we go. So now we have event data. Now with that, let's pull out the length of the data and the actual characters. So we should be able to do this. Yeah, so it's... If you wanted to learn more about what these are, we can go back to the data sheet and click on that event parameter structure, and then there's those two things that are inside of there. We're interested in the handle value pair. Let's see. So right, inside the handle value pair, there's the value, and then an attribute handle. And in the value itself, where is it? I hate it when it doesn't tell you, or it doesn't scroll correctly. Ah, here it is. There's a value, a length, and an actual length. I'm actually not sure if actual length just also includes the null character. You can try both. I've been using length just fine. So back to it. That, and then the value, and then there's the length and the value. I'm just going to copy this. And that should be the end of it, yeah. So we could say, what type is value? It's a uint 8. Well, actually, that won't work. We'll get to that in a second. Length, however, uint 16. So since this is a pointer to a string, the value, we have to do a mem copy like this. So mem copy works like, I believe it's the new string, the old string, and the length. So let's make a new place to put our string. So uint 8, we'll call it string of length 20. I'll just say it equals nothing, and then we can put that in memcopy. And then the string we're trying to take is this one. And we actually know the length. Okay. So there's how we can get the string from the write command. Let's do something to prove that we received it, right? What can we do? We could blink the LED for now. That's simple enough. Let's see if we're connected. It turns 0, whatever that is. So we'll say set it high, delay. You don't want to have too many delays in your Bluetooth code because it needs to keep running to stay connected. So try to keep it short. So that should blink. Let's go ahead and try it out. Okay, so I'll share my webcam. I'm going to use the NRF app again. I'm going to go to UART, connect. I'm going to go to the logs, and then at the top of the log window, I can click in there and I can send data back to or send strings back to the BLE chip. So I'll just type a couple letters, and then sure enough it blinks the LED. I guess it doesn't prove that we parsed the string correctly, but I mean it does prove we're in the right place. Okay, so let's write a function that lets us send strings back to the phone. Okay, so we're going to make a function that sends a string back to the phone. So let's go ahead and frame it up. We'll call it void NUS for Nordic UART server or service. Send string. And then we'll put in there a pointer to the string. So we have to build it up and then finally use the function that actually does the work, followed by the process events function so that it sends it right away. So let's figure out how we can do that. If we think about it, let's go to our top design. So we currently are receiving data with write or write without response. And then in TX, we only have notify. So we're going to notify the phone app of some data. So let's look for some way to use the notify. It won't be called write or read or whatever. It'll be called notify, so let's look for that in the data sheet. How about notification? Ooh, way too many hits. What else could it be? GATS, I think. There it is. Oh, this is like a help section. Okay. Here we go. CY BLE GATS notification. So that takes our connection handle, which we figured that out earlier. CY BLE con. There it is. And then whatever that is. GATS handle value in TF something or other. So we need to define that. So let's grab it. If I can. Oh, let's comment out that for now. What would they call it? NTF? Let's call it something that we can recognize, like notify handle. Oh, and then let's see what's in that. TF. And it doesn't seem to go anywhere. How about this? Okay, so it has a value and an attribute handle. So we'll need to set that up. And if you remember, value had two things. It had val and the length. We'll probably have to set that. Notify handle, attribute handle. So this is, so we haven't really gone over this, but we haven't done any checks to make sure it was the right service or characteristic in any of this. And since I don't plan on making any other services, I'm just trying to keep it that way, but we have to give it what characteristic we're referring to when we want to send the notify. So let's just double check. It is it's the NUSTX characteristic. So that is in the custom section of the BLE headers. Custom header. I've already forgotten it. My memory. TX. Right here, the TX characteristic handle. So I'll take that, put that in there, and then we can deal with the rest of it. Value, which has length and val. So for length, we could just grab it like that. So we can't just feed it the string from the function parameter. It gives us a little conversion issue. So we have to build another string just like we did earlier. It'll be something like string 2 of length 20. Actually, let's add one spot for a null character. We're going to add a null character to the end of the string, and I think that's how it knows when to stop looking for more characters when it transfers the data. What was it? Mem copy. Where it's going. What we're taking and how long it is. We can get that from string length again. And it's one longer because we're going to add a character. So the character we're going to add is the null character at the last spot, which is actually 20. Oops. Is that right? Yeah, I think that's right. Okay, it still says we have a type conversion issue. We could force it using this method. Now I'm curious. Let's just force it from the beginning and not even add the null character and just see if it works. Okay, now let's actually call this function. We'll just feed it right back to the phone. Any strings that we go from the phone to the chip, we'll give it right back. Right here, using this one that we set up earlier. Ooh, I didn't like that. Can we force it again? No, it doesn't like this. Oh, I see what happened. It's actually a character string. Character, uint 8 are basically the same thing, but anyways, it didn't think so. So now, as we get it, it should send it right back. Let's program it and test it out. Did we leave something commented? Yes, it's right here. We never uncommented the actual part that matters. Yeah, it just needs this handle we created. You have to put it in with the ampersand sign. Okay. One more try. Hello. Hello sent and hello received. Hopefully you could see that. I guess you can't. This webcam, I mean, you kind of make that out. I'll get a new webcam eventually. Okay, well, that is all of the important stuff. We can send and receive data to and from, in between the phone and the BLE module. This also works with Android phones. They both have the NRF app as well as the Adafruit app. Let's have a quick look at this app and why I think it's really cool. So inside of here we saw buttons earlier, and you can set what the button picture, the image is, and you can set the string that gets sent when you press it. So for example, you could just have a simple number, or A5 could mean something in your code, right? Create, and now we have an A5 button. Is that the name, or just, yeah, that should work. So let's press it. So data, you see data is getting, and we still have our blink on. Let's go to logs and scroll down. Yep, there's a bunch of A5s. I guess you can't really see it, but they're there. A bunch of A5s coming in, or coming back to us. They're bouncing back. You don't have to have that echo in there. That was just for testing purposes. Another thing I want to show is the other app real fast. The reason why actually, is it this one? Yeah, Bluefruit Connect. The reason why the Bluefruit Connect app is so interesting is, I think we need to close this one. There we go. Is that the buttons, even though they're preset, where are they? Controller? Control pad. The reason why these are cool is because it sends a string when you press it and sends a different string when you release it. It's way too bright. Let's see if I can turn the brightness down. Maybe if I move this out of the way too. Yeah, so now you can see the B516 was when I pressed it, and B507 was when I released it. And they're all like that. They're all individual, like the one key. So it looks like the last digit changes when you release it. It's pretty cool. So next steps, if you've gotten this far, would be to parse the string, like write code so that it understands what it has sent you. You can do it a few different ways. You can use the switch case method that we used earlier, or like we're in the middle of it right here. And then you'll want to send something to the PSoC chip that corresponds with whatever message you received. So it can be much simpler. It could be something like, the first byte is, the letter A, and that could represent, whatever. And then a number. The next byte could be a number that corresponded, like a command or, I don't know, a sensor value or something. So yeah, good luck.